So today we're going to be examining a particular assay used from this SLIR synthesis, localization, and painting and registration for image-guided thermal ablation of liver tumors. So the assay that we're going to be focusing on is image painting. And image painting is where you adjust for missing data in an image. And you can think of this kind of like Photoshop, where like if you're taking out a particular part of an image, a computer might be able to fill it in. So you can see that down in this image below. So we're all familiar with image painting. We just might not know the technical term for it. So how do we use image painting, especially in this study? So image painting results are calculated using what's called a peak signal to noise ratio, or a PSNR. And this is used as a quality measurement between an original and a reconstructed image. And there are two methods that one can use to do this, either a partial convolution or a convolution method. And both methods are able to process and fill in images using patterns in the images. And it's an amazing tool that physicians can use to see past an obstructed area. But the network that is able to do this requires a lot of training to be able to fill in what it can't see and begin to recognize these patterns. So researchers train the network before they use it on patients, and you'll see an example of this later on. So why is Inpainting important to this particular research? So the probe used to perform the ablation, which is just a non-surgical method used to remove a tumor using extreme temperatures, can actually interfere with a physician's ability to view underlying anatomy, which might hinder observation during a procedure because the surgeon is given different scans, but they can't actually see what's going on in front of them. So a partial convolution has shown superior performance in medical image painting. For medical images, they apply a 3D partial convolution to explore information in an image and paint what is obstructed, so what they can't see. And if the convolution is able to produce an output, meaning that it's able to fill in something on a particular location, the location will be marked as valid, meaning that it's like marked as done, and then it will move on to the next layer. And we use this 3D architecture because obviously human bodies are 3D, so we want our image painting to be done layer by layer so we get a really good and accurate representation of what the image is saying. So this is basically how Inpainting using a 3D architecture occurs. So we'll look at how this was used during the study. So the method to test this Inpainting was done by masking in a non-probe, non-artifact region using a randomly sized Biol cylinder. So what this means is that they covered up a part of the liver that did not have a probe or a part of a probe in it. So it's just the liver. And the masking was done in different regions for each of the 3 cases shown, and each case is a CT image taken during the procedure. And the goal of it was to train the network doing the Inpainting to recover the masked region. And the input was the image inputted into the network, and the convolution was a convolution method. And then the p-convolution was a partial convolution method. And then the ground truth was the original image without any kind of mask on it. So the partial convolution-based network was able to obtain an average of 7.12 decibels PSNR improvement and the coverage region compared to the convolution network. So basically what it's saying is that we see in this convolution, and you can really see it in case 3, that it doesn't match the ground truth very well. And then you compare it to the partial convolution and it does match the ground truth really well. So again, the ground truth, it was the original image. The input was the ground truth with an obstruction over it, and then the convolution and the partial convolution method were the 2 different Inpainting methods that were used to uncover what was covered in the original input. So where can we go with this? So researchers can use this data from the study to analyze the prospect of reconstructing tumors directly using a partial convolution-based Inpainting system.